Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to help you understand how to graph parabolic equations. So for starters, just a general understanding of parabolas. They have this type of shape to them. They kind of look like this. They can either open up, or sometimes they might look something like this, where they open down, right? This particular one, it kind of keeps going forever upwards, and this one kind of keeps going forever downwards. Okay, you have kind of what I'll say, like thin-looking parabolas, and then you have other ones, they can kind of look like this as well. Now, they all have a special point here, here, and here. This point is called the vertex of the parabola, and we're going to talk here in a few minutes about how you find the vertex. They have also what's called an axis of symmetry. This particular parabola is symmetric about this axis. This one here is symmetric about this axis. This one's symmetric about this axis. Now, I say they're symmetric. My pictures are a little crummy. These are quick hand sketches. In theory, they're perfectly symmetrical about these axes. When the parabolas open up or down, like these examples, the equations for these axes will all look like x equals some number, right? Now the vertex itself has coordinates that I'm going to call h and k for a moment. And when a parabola is written in this general form, a number times x minus h squared plus k, then the vertex is given by the point hk. When the number out in front, this a term, is positive, the parabola opens up, such as this example. When the number a here is negative, and again you'll see examples of that, the parabola opens down. It looks more like this, or possibly this one. So one way to graph a parabola is to put it into this mathematical form. Look at the a value here. If it's positive, it opens up. Negative, it opens down. And then the vertex is the point hk. That's usually enough to get your sketch started. Another good thing to do is graph a few intercepts, maybe some more points, and you're on your way to graphing it. The other way to find the vertex of the parabola, right? This is another kind of general mathematical form for how parabolas can be written, like ax squared plus bx plus c. The coordinates of the vertex are given by minus b over 2a. And again, I've got another video on why that is. I'm going to save that for another time. I don't want this to get too long. So one way to find the vertex when it's in this form is to calculate this value. Whatever that value is, plug it back into this equation for x and get the y value out. And in this language here, that would tell you the k, if you will. Right, so the x coordinate of the vertex is what we're calling h over here. And then you plug that in. F of this thing gives you the k value. And then you can start sketching your parabola. So that's kind of the general idea. I'm going to go through some examples now. Let's get rid of this. All right, so we're going to start with the parabola y equals x squared minus 9. Pretty simple example. Now, which of these methods? In this particular case, I'm going to go ahead and choose this method here for graphing it. So again, what I want to do is make this look like this. And this one's real simple here. All we have to do is write it x minus 0, the quantity squared, minus 9. I think everyone watching this hopefully will agree that these things are equal. Now I'm just going to compare x minus 0 to x minus h. Right? The h is equal to 0. The value for k is here. K is minus 9. So now what we know is that the vertex is at the point 0, negative 9. Forgot to write the minus there. The a value, if you will, here is plus 1. So this parabola must open up. So now I've got enough information here to start plotting points here. So I'm going to go to my vertex, 0, negative 9. So 0 left or right, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my vertex. The parabola opens upward. Now, that gives me lots of possibilities here. Perhaps it looks like this, or maybe this. All right. Well, to get a little more detail, I'm going to go ahead and find the intercepts here, the x-intercepts, by setting y equal to 0 and solving for x. It's pretty easy one to solve. We get x equals plus or minus 3 out of that. And that means that one of the intercepts is 3, 0. 1, 2, 3. Another one is negative 3, 0. 1, 2, 3. And now I got quite a bit of information here. I'll just sketch the rest of this by hand. Probably looks, maybe something like this. And again, this is a hand sketch, so it's not perfect, but there's a graph of that equation there. Good enough. If you wanted more detail here, you would just plot more points, like maybe put in f of 1 and get a number, f of 2, get a number, and then maybe f of 4 and get a number if you want more detail. The point of this video is just how to get a generic sketch here, so I think I'll just leave it at that. So let me get rid of some of the stuff here. And get rid of this. And go through another example. All right, let's try this one. Y equals x squared minus 3x plus 2. All right, so I'm going to go ahead and use this method again. I want to try to make this look like this. And in order to do that, we're going to have to complete the square on this, everybody's favorite method. So I'll give myself a little space here. Now I take a look at this and I say to myself, what do I have to add here to make this a perfect square? And you look here, that's a negative 3. Cut that in half, right? That's negative 3 halves, and square it. That's 9/4. So I'm going to go ahead and add 9/4 here. Now remember, equations are kind of like teeter-totters here. We've got to keep this balanced. Right now I'm heavier on the right because I just added that 9/4. To fix that, I can either add 9/4 to the left or come on over here and subtract 9/4. I'm going to go ahead and do that. Don't need this anymore. Alright, so what we have done now is we have designed this to be equal to x minus 3 halves the quantity squared. Let's go ahead and simplify this while we're at it. Common denominator is a 4, so this thing is 8/4 minus 9/4. That's negative 1/4. I'll just put minus 1/4 there. All right. Okay, we're ready to kind of sketch this, I think. So taking a look at this now, the a, if you will, is 1, so we know this thing opens up. Now we're going to compare the x minus 3 halves to x minus h. So h is 3 halves. And then compare these two. K is minus 1/4. All right, so what we know is the coordinates of the vertex are at the point 3 halves minus 1/4. So I'm going to come over here and plot that point. Actually, to tell you the truth, I'm going to do that later just because of the way my computer system works so that I can easily delete it. So we'll put that on hold for now. Some other information that would be good to have would be the intercepts. I'm going to take a look at this right here. Let's get the x-intercepts. We can do that by setting y equal to 0. Solving for x. I think this one's factorable. It's looking like x minus 2, x minus 1 to me. Yep, that works. All right, so the solution for this part of the equation is x equals 2. So we know it goes through the point 2, 0. The solution for this one is x equals 1. So we know it goes through the point 1, 0. Okay, we've got lots of information now. Let's go ahead and start sketching this. All right. I just found the intercepts, so let's go ahead and do these. Let's see. 1, 0 is here. 2, 0 here. 3 halves, negative 1/4. So 3 halves is 1.5, and negative 1/4, we're just barely down here. Okay, so I've got a lot of information kind of really, oops, sorry about that, real close here. Another good thing to do with when you're graphing parabolas, let's get this intercept as well, the y-intercept. It's usually really easy to get the y-intercept of a parabola. Just set x equal to 0. So looking right here, if x were 0, y is 2. Let's put that one on there too. That's enough to start sketching this. Our parabola is looking something like this. maybe one more point. 1, 2, 3. If I put 3 in here, we get 9 minus 9, 2. So 1, 2, 3, 1, 2. There's one more point. That's good enough. So there is a graph, a beautiful looking graph of our parabola. Oh, one thing I probably should have did on the other ones that I'll go ahead and do in this example is to discuss domain, range, and axis of symmetry. The axis of symmetry is this line right through here. It's described by the equation x equals 3/2. There's our axis of symmetry. Let's talk domains and ranges. So for the domain of any function is the values of x you can put into that function and get a number out. Now, this thing right here, there's no value of x I can put in that's going to give me any problems here. So the domain of this thing is all real numbers. It's a symbol for all reals. Range. So what you typically do is look to your graph for the range. This function is, y values are only above this point here, and this point is y equals negative 1/4. So our range, let's write it like this: y has to be greater than or equal to minus 1/4. All right, and we're done with that. So the point of this video was how to graph parabolic functions, and I've seen it's getting a little on the long side, so I think I'm going to just stop this video right here. A little bit about how to find the domain and range. I hope that this video helps demonstrate these concepts. Have a great day.